Hi, my name is Kelly. I'm a solutions engineer from RStudio here, and they sent me to talk to you all about what we do at RStudio and who we are. So first off, RStudio is a software company. We develop open source and enterprise-ready professional tools, and we're really fully committed to the idea of supporting the open source work and this R ecosystem. So in order to do that, we hire a bunch of really great software engineers and educators, and then we give them the resources and tools that they need to develop and build in this space. And then, in order to fund and support all of the work that they do, RStudio goes ahead and hires even more wonderful, excellent software engineers, and their job is to build our enterprise-ready professional product suite. So to support those products and engineers, we hire yet a few more enterprise advocates, customer success reps, support engineers, and solutions engineers such as myself. So at this point, I've either made RStudio sound like very straightforward or highly complex. I'm not too sure, but the TLDR here is that while we give a lot of our products away for free, we also have a fairly traditional business model in that we do sell software. And there are a lot of ways to support the development of great open source work. So sometimes we get the question of like, why do you guys bother with these professional products? And I am not quite the right person to stand up here and tell you exactly why that is, but I can speak to it kind of from my position as an R user and as a solutions engineer from within RStudio. And to me, what makes supporting these professional products worthwhile is that I think it's really cool to position R as a viable analytic standard in the enterprise, because it really helps the development and growth of the maturity of our R tool chain and therefore the health of the R community as a whole. So the R community as a whole, speaking of which, has put a lot of effort into the developing of packages and workflows that make our common data science toolset highly desirable to everybody. And great tools or great software is built as much from the vision and having that available as it is from astute observation and intelligent information gathering. We get a lot of really good information from our open source and nonprofit and academic communities. So that information and those conversations are really inspirational in how we build our tooling. But there's much less communication, at least through public channels, coming from our industry folks. And that's understandable because it's kind of how that works. But it's also kind of a shame because really interesting things happen when these organizations accept and embrace R as an analytic standard. So every customer environment is interesting and challenging in new and different ways, and every industry brings new and challenging problems. So the R professional product stack is a set of tools that we've designed to help data science teams that are interested in scaling and sharing their work in robust and secure ways. And in the process of offering support channels for our professional products, we get to ask some pretty cool questions. And specifically, I get to ask these questions. And they're basically the same questions that we ask of our open source users, but they tend to be really interesting and informative in how we build our products. So when you ask, why bother with these professional products, that's one of the big reasons why. I think the R for data science workflow is a cut above the rest because as a community, we're open to incorporating feedback from all available channels. And this is also really key, I think, in being able to continually develop great software, open source or otherwise, and doing our part at RStudio to keep the R language vibrant and strong. So now I want to share a couple of the things that we at RStudio have been up to over the last year since we were at UseR. And I'll continue to frame these things around workflow and the options or decisions we have as users of R to design how we do our work. way back in 2016, Hadley and Garrett published this book called R for Data Science. And one of the most profound and, in my mind, underrated chapters of this book is chapter 8, which implores us to think consciously about projects in the macro sense. So what about your analysis is real? Where does your analysis live? What will be saved as the lasting record of what happened? And these questions then translate into how you choose to structure your project analysis for peak productivity and functionality, reproducibility, and collaboration. Now, in 2018, these days, many of our workflows are driven by the need to produce and communicate through data products or artifacts. And those data products and artifacts often require integration with external data sources. So we have new concerns coming in about scalability, usability, integration, performance, and these issues have been a catalyst for developing powerful new options that we can use to get way more granular about the decisions we have and create around project design decisions. So I'm going to talk about them in three broad categories today. Where, how, and when, and specifically in regard to computation in R. So first up, I want to talk about user experience and communication challenges at scale. This past January at RStudio Conf, my colleague Sean ran a live demo showing that a Shiny app could be scaled to serve 10,000 concurrent simulated users. And then he went on to log in and become the 10,001st user on that app. And this was the first time that we had pushed Shiny to this level. So it was pretty interesting to see, how the process would break down and what it would uncover. So you can check out the recording of that talk. It's available on our website, and check out all of the infrastructure and strategies that were implemented in the final solution there. But this focus on making Shiny easier to deploy into production has resulted in at least two packages, and two that I'll mention here: Shiny Test for automated testing in Shiny, and Shiny Load Test, which would have been really useful in Kevin's workshop yesterday if you were in that. But Shiny Load Test is almost not quite ready for prime time usage, but we do have a webinar scheduled on it for August, so it sounds like it will be ready soon. So check that out. In parallel to that work, there has been a significant release of the Shiny package itself. And this release, among doing other things, supports some really interesting work around asynchronous programming. So you may be interested in this if you ever tried to build a Shiny app to serve many users, but has a single long-running process that will tie up things in your app for different users and kind of stalemate your app and your user experience there. So for that, Henrik's Future package provides a really nice way to launch tasks off of the main R thread. But we needed another package to retrieve those results and get them back in. So this step is handled by the new Promises package, which introduces the concept of promise objects and promise pipes. But full disclosure, and Joe says this as well, it might take you a few moments to wrap your mind around what's happening here computationally with promises. Joe has a webinar available on this on RStudio.com, as well as he's written extensive documentation, which he highly recommends reading before jumping in. So if the idea of using a promise pipe, not to pull future values to the present, but to push subsequent computations into the future, is a bit mind-boggling, you're in good company. So do check out that documentation if you plan to use this feature. So that was the when of computation, and now I want to talk about where. And when I think about the where of computation, I'm usually thinking about where my data is and whether I need it to be here, aka in R, or whether it's desirable to keep that data and the computation there, as in someplace not in R. Perhaps you have a lot of data, And the sparklyr package was big news for us last year because it opens the door to our users having a really powerful interface into one of the most popular technologies for doing distributed analytics at scale, and that's Apache Spark. Last summer, the sparklyr package had its 0.6 release, which was a big deal, and Edgar and Javier had kind of a webinar bonanza in last August. So those still remain really great resources, but work has continued on the sparklyr package, and what I want to bring to the front today specifically is the idea that using Spark in R is kind of a prime example for having to shift your idea of how you structure your workflow design model. So if you're using Spark as an analysis engine, you should be leveraging this push compute paradigm. In other words, when you use the sparklyr package, you should be making a conscious decision to purposely fragment your data science workflow. You use sparklyr as the tool for orchestrating all of this tidy, transform, model work, but that's all handled by Spark and not R. And then you can eventually collect your results down back into R memory, but hopefully at that point it'll be small data and you'll be using it just for communication and visualization purposes. So the same paradigm applies in varying degrees to when you're using and working with other sorts of data connectors in R as well. We recently introduced the new connection pane in the RStudio IDE, and that can be used to manage your connection to Spark as well as other data sources. There's also a new suite of professional drivers available for download and use in all of our Pro product licenses. So if you have one of our Pro products and you're interested in getting access to these drivers, they're free for you to download. In support of all things databases, we've launched a new web page called db.rstudio.com. And this site has a lot of really great material in it, in particular suggestions around good design principles, how to be smart about where your calculations are taking place and when to pull data back down into memory in R. So this enterprise-ready dashboards article by Edgar outlines a bunch of those best practices and provides some very great working examples for implementing those suggestions. And again, the common theme here is that number one suggestion is to push as much of the calculation work out of the dashboard and onto the database. So finally, I want to talk about the new things that are happening around how we do data science. So questions like, how do we use tools that are outside of R? And I kind of touched on this when I talked about the integration support we're doing for Spark and for databases, but there's something even newer for us in the idea that we want to be able to facilitate seamless multilingual workflows in R and RStudio. So this brings us to the idea of interoperability. And it's actually quite an old concept, but it has a lot of new buzz in data science right now. Very basically, it's the idea that it would be nice to use other languages in systems seamlessly within R, and then conversely, use R seamlessly within other languages and systems. So the tools that I'll show right now probably fall closer on the spectrum towards integration rather than interoperability, but they do represent kind of taking small steps towards a future of interoperability for us. The Reticulate package offers an R interface into Python, and it facilitates doing things like calling Python from R in a variety of ways, as well as very helpful translation between R and Python objects. This demo here, Reticulated Shiny, is running in our booth when I have my computer hooked up sometimes. And it's a really cool example that my colleague Sean created based on a Python model that one of his old colleagues had done in R, in Python. So he had this, 500 lines of Python code, and wanted to build a Shiny app around it, but didn't want to replicate the work already done in Python back into R. So with the Reticulate package, you can do that. You can pull Python code into R, use it, create a Shiny app around it, and do very powerful things working with two languages at once. Let's see. So you can use the Reticulate package to get Python into R. But then what do you do to get R into Python or any other system or language? For that, I will suggest checking out the Plumber package and learning about what building REST APIs can offer you. So you can use the Plumber package to turn your R functions and endpoints into these endpoints that can be served and then interacted with through any other language or system that has the means for interfacing over your common web communication protocols. REST APIs have been lauded since, the beginning of Web 2.0 as a path towards better interoperability. And so, it's kind of very strange and funny that I'm ending this talk on what's new with RStudio by talking about something that is very quite old, but I kind of like it, and it's kind of fitting in a sense. I found when I was looking up some things about Web 2.0 kind of for fun, that according to Wikipedia, that this term was first used in January 1999 by Darcy DiNucci in this article called Fragmented Future. And I know that standing up here I might be a little bit too young to be making callbacks to technology paradigm shifts from like 20 years ago, but believe it or not, I do remember Web 2.0 being a big deal. And data science, I think, in many respects is still a very young field. And I think I really like what Darcy says here is an embryo of things to come. Our workflows, have these growing pains and can often feel quite fragmented. And today I've made a case for fragmenting your workflow purposefully. But with all that in mind, I'm not sure if what we're experiencing today is anything akin to Web 2.0, but I do know that the landscape of data science workflows is changing really rapidly, and I'm excited for myself to be involved in any small way. So I joined RStudio because I personally feel very strongly about being excited about what's happening and helping to shape all of these disparate ideas and needs into useful tools and software. And I'm really excited about what's to come, so if you see us, come visit us at the booth and come talk to us or get in touch with us online. Thank you.